Hi everybody. This stream will be about coding interviews. I will solve some problems from LeetCode, I guess, and I want to focus on TRIE, that data structure that is able to hold some information about strings. Hi Alekshay, Hercules, Naz, LeetCode patterns. How official is this list? Do they have try tag? They do. Okay, that might be useful. We'll take something from there. All right, what about the first one in the list? Maybe before I look at particular problems, let me refresh your knowledge about TRIE. For that, we for sure need a drawing. What is TRIE? Actually, let's go full screen with this. If you don't remember that, then don't worry. TRIE is this structure that gets every next string and it creates a tree starting from some empty root, and it puts edges down towards children along with the characters that we use in this string. For example, if a string is banana, then we will have here an edge with B, another edge with A, another edge with N, then A again, and so on. And here in this bottom node, there is the end of word banana. If there is another word, let's say the second word in our dictionary is bad, B-A-D, then going from the root, we will first use the existing edge of B, then A, then D. And here there is node denoting the end of word bad. Those nodes, I think they are sometimes called terminal nodes. Anyway, they represent the end of some string. If there is also a word, what is some short word I, it looks like this. This is how a trie looks like for words banana, bed, and I. How is this useful? We can very quickly check if there exists a string with some prefix. If now they ask us, hey, is there any word in this dictionary with banana, bed, and I that starts with BAB, then we can check that instead of checking every word separately, because maybe we have millions of words, we will just go starting from the root and we will follow the characters. First we use B, then A, then B. We go B, we are now in this node, then A, we're now in this node, and then we try to use B, but there is no edge with character B. There is only D and N. There is no B here. So apparently there is no word that starts with B-A-B. That's the main feature for now, to check if there is a word starting with some prefix. And we can use this to solve a problem like this. Implement a feature of suggesting a word in your phone, or also could be computer. And that's when you type something in your phone, you start typing and let's say you say B, A, then this phone will suggest to you the best possibility of what you maybe want to type. It will suggest some word and you can click it and then you're done. You don't need to type the rest of the word. So always when you already are done with some prefix, the phone should suggest the most likely full word starting with this prefix. If I type BA, my phone maybe will suggest bed or banana. And among the possible suggestions, let's say that I typed only BA. Then I'm in trying this node, this one. And I would say that the phone should suggest to me the most common word among those starting with this prefix. There are some slightly better heuristics, but maybe we want to suggest a very long word, because if you want to type bed, then what's the gain of suggesting bed after you already typed BA? Nah, that's stupid. Maybe let's suggest banana, just because if a user wants to type banana, it's a very long word. Yeah, but it makes sense to say the most frequent. So if every word also has some frequency, let's say in English maybe word banana has a frequency value of 30, whatever that means, bed has a frequency value of 200, and I has the frequency value of 40. And then if a user typed already BA, then we want to suggest to them a word bed, because that's the most frequent, the most common word starting with BA. This is the most common use case of TRIEs, where we deal with dictionaries. But we'll also see some problems, and they appear in coding interviews, where we deal with binary representation of numbers, and then this might also come useful, especially when we deal with bitwise operations like XOR. But in real world, I'm sure that this is more common. You know, this is a very real-world example. Suffix trie instead of normal trie. I mean, if you want to care about suffixes instead of prefixes, then feel free to use suffix trie if you want to go with words from the end. Right, now that we know something about tries, let's look for any problem that will let us actually implement something. We're given strings. Return the longest word in words that can be built one character at a time by other words in words. Because of low constraints, I guess that there will be other solutions as well, but maybe we will try to do this with trie as a practice, as an implementation practice. We are looking in the dictionary a sequence of increasing words, such that always when we have a word, and we add the next character and we have another word. In this example I marked, we can start with A, then go AP, APP, APPL, and so on. And eventually we will get apple. We ask, is it possible to choose some string, let's call it S1, and then choose S2, S3, and so on. We want to choose as many words as possible, and there is a condition. Every next word is the previous one plus one new character. Or, in other words, it's about some kind of game where you need to type a very long word, like apple, but there is a condition that every partial word that you wrote also needs at every moment be a valid word in the dictionary. For example, apple here is valid only because every prefix, like app, up, is also good. Good means it is inside this dictionary. If I wanted to do this without a trie, for every string, for example for APPL, I would check if this string without the last character, if it is in the dictionary. Like what? So first, maybe this is not enough. For every string, consider a string without the last character. Shorten. Okay, shorten is fine. Shorten dot popback. This removes last character, and here check if this shorten is inside the dictionary. Then we need something like the longest path in this graph of connections. So APPL is good if APP exists and APP also it has that shorter word and shorter word. So we can say APPL is good if APP exists, the shorter word, and APP is good too, where good means that we can create it. Then check if this is inside the dictionary. Actually, I will create dictionary as a set, because in set I can very quickly check if something exists. Let's call it dictionary. Now I'm grabbing this vector from the input and casting it to set. Now it's a set, so if dictionary contains this shortened string, and also this shortened string also is good, which means that that one was possible to be created by removing the last character, maybe good count shorten. Then this, and there is set of good strings. Those can be created character by character. Also, if something is a one character, then it can be created. So if either here, what do I want? Maybe here. If the length is 1, then good, insert S and continue. If something is one character, like just A, then yeah, sure, you're good, I can create you. If you want to create APP, I need to check if AP is in the dictionary and if AP was good, which means it could be created by A. But if I do it just in this order, it will be bad. I mean, this solution is wrong right now, because as I go through the strings, I'm here at APP, I will check if AP exists, that's this string. I will check if AP exists and if it's already marked as good. And eventually AP will be marked as good, as creatable, but not yet. We need to sort those strings by length. So always when I look at some string, all the shorter strings were considered and possibly inserted into good strings. So the words I will sort by length, from shortest to longest. For speed I can do this, but it isn't very important. Just compare them by taking strings by reference rather than by value, to avoid some unnecessary copying if strings are long. Okay, and then I care about the longest string I can get. Answer is 1. Answer is here not insert shorten. I am good because shorten was already marked as good. I overwrite rather than typing, answer is maximum of answer and s.length. This would also be a correct line, but I know that if I consider them in increasing order, if I see a string of length 7 and I see that it's good, I can create it, then I mark answer as 7. The strings so far could only be shorter than 7, so it's okay to overwrite. Set will sort the strings lexicographically. Yes, that's right, but it's more complicated to analyze what happens then with order. Instead, I just sort words, the vector. And yes, I agree that lexicographically would be correct as well, but it's less trivial. Let's talk about it in a moment, some more. Answer wrong, why? I need to remember that string. So this is not right. Maybe this answer is empty by default, and here I overwrite answer with s. We don't need to return the length, we need to return that final string. works here. Submitting. I guess it's about ties, right? Return the longest word with smallest lexicographical order. Okay, if there are ties, I need to choose the lexicographically smaller one, which means that I will, I think, have a function. And what it will do is either if this new string is longer than the string found so far, then override, or if it's the same length and s is smaller than answer. It's impossible that the new string is it's impossible that the new string is shorter. It can only be longer or equal size, because I know I go from shortest to longest. I have now this function consider, which is a bit more complicated than so far overwriting, because in case of ties I need to compare lexicographically. This is comparing two strings lexicographically. And now I will call consider of s and consider of s again. Min doesn't work on string. It does. It gets lexicographically smallest of the lexicographically smaller of them, but it doesn't compare by length at all. And something is wrong. Yeah, I shouldn't overwrite and then consider. What was here before? I should replace this with consider of s. Instead I replaced this inserting good strings, which stopped me from later seeing that something was good. I should have just replaced answer equal s with consider of s. Right, submitting again and accepted, but we're not quite done. One thing is, this problem can be solved just by sorting lexicographically. You know, if you sort words like this without any extra comparator, it will sort it lexicographically, and then still maybe some shorter words are later, but that's not an issue. In a real dictionary, which is sorted lexicographically, but will be before banana. And if there is a word ban, it will be before banana. That's very important. Like if one word is prefix of the other, maybe also there will be words like bana and banan, they will be sorted properly. Maybe with some other words in between, like banaba, say. Still, those are done in correct order. This is not sorted by length, this is sorted lexicographically, but when you consider banan, for sure, bana, with a at the end, it is already considered, so if it's good, it will be marked as good. So we are good in terms of order. As long as, always, when you look at word and you consider removing the last character, this shorter word was already considered. Set is already sorted, yes. So it's fine to iterate over words in this set. If you basically putting everything into a set automatically sorts stuff for you. So sure, you can now iterate here not through words, but through dictionary instead. That being said, you know, I didn't want to rely on the fact that this set is sorted. We could also use here unordered set to get rid of logarithm in complexity of checking if some string exists. Not that it's very important, because we sort here anyway. But well. What else? Oh, another thing is that we can avoid sorting and I think logarithm completely if we just do kind of radix sort. So instead of sorting, just group by length. If there are different words like bed, ban, bana, and so on, they don't need to be sorted like this. I don't care what's the order of those two in particular. It's enough for me if they are grouped like that. So when I see a word S in the input, I can do group, let's say, of s.length pushback S. This is like radix sort, where you don't really sort fully, but you put into groups, into some kind of buckets, and thanks to that, it is linear. And lengths are limited. It's not that length can be up to billion and you need to here create something of size 1 billion. No. And with this, you can solve the problem in linear total time. Right? Yeah, I think it's just linear of the input. There is no logarithm, there is no quadratic, because we don't iterate over pairs or anything like that. You cannot beat this time and space complexity. Still, we wanted to practice TRIE, and let's see how we can do it. I'm looking for those increasing words. What does it mean for the TRIE structure, which I created here? Remember, every node is, let's say, terminal node if there is a string finishing right there. But what it means, if there is a sequence of those special words, like A, then P, then P, L, E, is that every node in a row will be marked as terminal. After you put all the strings into this structure, the next step is to find, starting from the root, the longest path with terminal nodes, which can be achieved just by running the FS from the root. You can run the FS and only go to a child if it's marked as the end of some string. If here you have, let's say there is also a word, Alice. Like that, and this is the end of that. But there isn't word al, al. Then this node is not terminal. So with DFS, from the root, you will go here because this is a terminal node, a child which is marked as the end of some string. But from there, you will not go down to this child. So you will not go to Alice, because indeed, Alice cannot be created because there isn't a word al. Then this is a nice solution. If you know how to create TRIE out of the given strings, after that, and marking proper nodes as ends of strings, it's about running the FS from the root of this tree, because TRIE is a tree. This might be confusing to hear, but TRIE is, well, type of tree. TRIE is just very special tree. You run the FS from the root of this tree, of this TRIE, and you go down and you ask about the deepest terminal node. If there are ties, then you always prefer to go first to the left, more to the left, if edges are sorted by character. So you prefer to use A first rather than B, because you want to get lexicographically smallest string. Yes, this software to draw is one node. But don't we also need to sort lexicographically in buckets, because bed can be entered after ben? In terms of this depends on the implementation of TRIE. One possible implementation is that in every node, like here in this node, we have an array of pointers or ints, let's say pointers to nodes, to all the children, and that's of size 26, which is equal to alphabet size. This makes the whole thing to be n times 26, or n times alphabet size, but it is then very fast. It's very fast to go down to any kind of node. While otherwise, if you don't have this array, then you need some kind of map for every character When you are in a node and now you want to use character B, you need a map to say, given this character, to what node I get. So that's a map from character to point to nodes or pointers to nodes. This implementation with array of size 26 in every node is very convenient. Believe me, it's not asymptotically the best, but it's still very fast and convenient. And then if you have that, before I go to coding, I need to talk some more. If you have that from every node, you don't need to sort, because you just iterate with characters from 0 to 25, because that's the array of size 26. Every slot is for character A, B, C, and so on until Z. You iterate from 0 to 25, and you use the first available edge, let's say. This is how you would prefer A over B. Why is TRIE named so? I don't remember, to be honest. But I can check. TRIE. It comes from retrieval. TRIE is from retrieval, which actually suggests that we should say tree. But then it suggests that you're saying TREE, then I think TRIE is much better. Right, then let's implement TRIE. This was my previous code. Sure, it's fine, but we want to learn something else. That actually might be much more useful in other problems where there will be no simple solution. This problem is easy anyway. This is why there exists a solution without TRIE, without this special data structure. But in some harder problems, you need to actually use TRIE. First, we need to create. For every string in words, we need to start from the root and use the characters. I always do it like this. For every character in S, starting from the root, and let's say that the root is node 0, I always use a map, let's say next of root and then C. Let's say. Okay. For example, if not next of root, okay. Next of node 0, this is ID of node that we get after going from this node with character A. This will correspond to character B and so on. This is character C, D, D, and so on. Maybe I shouldn't say root here, just the current node. But of course we start in the root, 0 is the root, and then we keep going like that. Node becomes the node which is child of node with this corresponding character. I subtract A to get a value, integer value from 0 to 25. Assuming that this node exists, then this is fine. And here I should say terminal, or is terminal of node is true. This means that this is the end of some string. And here next is, for now let's just assume that it's an array like this. Some big size, 26. We will improve that. It's ugly, you shouldn't use exactly this thing. Now, sometimes a child doesn't exist, right? If we wanted in this try, if let's say banana was already added and then we add a word bed, then when we are here and we want to add character D, such child doesn't exist. So we need to say, if from the current node, the child, like here, child with character D doesn't exist, we need to create it and assign a new node ID. If next node C minus A is 0, then this is let's say plus plus n. Something like that. So this will always be the next available ID. So let's see an example of what it will do. Say we first add a word bed. Bed is the first word. 0 is the root. We move with edge B, with character B, and we need to create a new node. It will get ID 1. Then from this, with character A, we get the next available node, plus plus uppercase N, it will give us 2. I used too big of a font in top vertices. Start from 0, B, 1, A, 2, D, 3. And now if we add banana, we start from the root. The second word is banana. We start from the root. We go with B, we are in node 1. We go with A, we are in node 2. Now we go with N. This child of 2 doesn't exist. So the next, we check that next of node 2 of character N, or actually this character minus the character A to get value from 0 to 25. This is right now 0. So when we say this becomes plus plus N, we just make it the next available ID, which is here 4. Then below will be 5 and so on. And that's the idea. And the root is 0. Every next new node will get the next available ID. And after we actually assigned to this child some ID, we can move on. We can move to this child and continue our journey. His terminal is a sequence of this Boolean sequence. Again, I will later modify it because I don't want to use those big arrays of fixed size. In particular, because LeetCode runs your code for multiple test cases, and I would need to clear those arrays, otherwise I will get wrong answer. Right. And what then? We added everything to try. Now we need to run DFS from 0. For all the possible children, so for some kind of C, from 0 to 26, if there is such a child, and it's marked as terminal 2, then go there. I repeated the same thing 3 times. I wrote it 3 times. Maybe let's create here a helper variable. TMP is that new candidate for a node. If it actually exists, 0 means that it doesn't exist. And it's terminal, then go there. Okay. And here's a nice trick. When we are somewhere, we want to know the string, how we actually got here. I will pass, how can we go with that? We will pass the string, let's say, so far. When we are in DFS and we are, let's say, in this node, so far we will have BA, because BA are characters we get as we go from the root to this node. So we get the string so far. Always we consider this to be the answer. So if so far length beats answer.length, or lengths are equal, but so far is lexicographically smaller, then we should override. Like this, and then we move down and we pass the string so far, we append it with with what? With character C. I need to here add a to actually make it a character, not a value from 0 to 25. Then answer needs to be global or passed as parameter by reference. Let's go with the latter because it's nicer. And here initially answer is, let's say, empty. To run DFS for node, we start with empty string, we pass answer, and then this string so far will grow, and always when we are somewhere we consider this to be a new answer. Cool thing is, now I don't actually need to care about the order of edges. I will visit all the vertices that I can get to from the root, moving only through terminal nodes. And each of them will represent possible answer. For example, if here I said that all of those, A, P, P, those are terminal, it means that A is a correct word, AP is a correct word, I mean good word, and APP is a good word. Each of them could be the answer. I can make some speed ups here, like if I will go to at least one child and it's also terminal, that actually I cannot be the best answer. I don't think that will affect the time complexity. Right now our time complexity is the number of nodes of a trie times 26, and we need to actually understand what is the number of nodes in a trie. Am I missing something? I told you that we will not use big global arrays. Instead, I would prefer to use vectors. Like that. Now, always when we start a new test case, let's just clear this completely from the previous test case. Or should I pass it here? Yeah, let's make it very, very nice. Nothing global. Then this terminal. Initially with just a single value, false, because the root isn't false. Okay. And next, of size 1 by 26. This will just represent all the children nodes from vertex 0. All the values are 0 by default. I could type this. What I'm creating here for now is the array 1 by 26. I will keep expanding it. And this is array just is terminal of 1, filled with false. This is filled with zeros. I could also say this. And whenever I create a new node, I need to assign one more row in this vector and in this vector. So next, push back a new vector of int of size 26. This terminal. Back false. So this will always be of size number of nodes in the tree, in the trie, and same for this guy. It will be number of nodes in the trie times 26. But then I need to pass both, which is a lot of typing, I would argue, but on the other hand, this is how you should really do things in C++. Don't create global variables if you don't need to. And done. This is a solution with a trie. It is harder than the first solution, but the point was to make this educational. Not only to get the easiest solution and move on. Alright, what do you want? So far, answer. I cannot add like this. Maybe you will allow me to do that. create a new string of size 1 with this character. Maybe then I can concatenate. Maybe what about this? Now it works, but also maybe just it was about casting to character. Maybe this is treated as int, and then it doesn't want me to say string plus int. Now I explicitly cast to character. Yeah. Submitting. And accepted. The runtime is better because here we have some extra logarithm and the set. Set is very slow. This solution is much better. Okay. And magical improvement will be that I can remove this line. And we will try to understand why this is true. Before that, so that I wouldn't embarrass myself, let me check that for sure this is correct. I will submit, get accepted, and then explain. Would be pointless to explain why this is true and then to see actually it isn't. Yeah, it worked. What did I remove? We had this. If so far there is some answer, the best answer I got, the longest one in case of TRIE is the lexicographically smallest. That's always stored in variable answer. So far I have this current candidate for the answer, and I say if it's longer than the best answer so far, or lengths are the same but this current candidate is lexicographically smaller, then override. But here's the thing, always when I move with DFS through this TRIE, I go in order of increasing edges, A, B, C, D, E, and so on. When I start from the root, I first consider using A. Maybe this is terminal node indeed. Then maybe I try to use A again, maybe that guy doesn't even exist. I try B. Maybe this exists, but it's not terminal, so I don't go there. I try C. Maybe indeed there is something here, and there is a word AC in the dictionary. Then I move on and so on. In particular, right now, I already have possible answer AC. And much later, whenever here I'm considering something like AD, AF, AE, or when I'm considering later other edges from the root, like here, I say E, and then Y, I'm going to I, E, Y, E. Let's say there is a word E, 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 Y, right? I know that this is lexicographically bigger than the previously found AC because of the order of edges I use. I first consider small character A to use. So everything ending there, all the strings represented by paths from the root to something in this subtree, they are lexicographically smaller anyway than all the strings ending there. So the only possibility for me to go with DFS for this part and override the answer, the only possibility for that is to find strictly longer string. This is why checking if in case of a TRIE we have now something lexicographically smaller, we don't need to do that because it never happens. Because I consider children in order of lexicographically increasing characters. Which makes this better because it's even constant now. This is constant time. Previously it was linear because when we compare two things lexicographically, that's linear, we go character by character. If we really want to make this fast, maybe also we should not copy string so far every time. Let's pass it by reference, but then I will first, before going deeper into recursion, into DFS, I will add this character to the end. So I'm appending this character to so far, and then I need to push back. Sorry, pop back. I need to cancel that. So let's say I have AP, and then I consider the next child to be A. Sure, maybe APA, and I go recursively deeper into DFS, but then I need to pop this and consider maybe APB, maybe APC, and so on. I think this will not compile. I cannot pass empty string and say it's taken by reference. I actually need to create it. I'm not sure if running time will be better, but there is some improvement. Well, yeah, some improvement. Right now it's easier to say what's the time complexity, because always when I go into new call of this recursive function, it's constant complexity. And here then I iterate over 26 children. Now, number of nodes in the whole trie cannot exceed the total length of input, which is the sum of strings in the input. Because if you have string of length 5 in the input, you get at most 5 new nodes. From the root, you go 5 times down, maybe creating new nodes at every step. So this is the worst possible case for the number of nodes. And then DFS will have complexity of number of nodes, which is total length of the input, times 26, because here we iterate over 26 children always. We can say that this is limited even more, because we go down to in DFS only if I am a terminal node, if I'm the end of some string from the input. So even better, I can limit it by n times 26, where, or maybe lowercase n, where n stands for the number of words in the input. That's this, words.length. That's much smaller than total length of input. They can give us 1,000 strings, each of length 30, and total length of input would be 30,000, while number of words, this lowercase n, I decided, it's 1,000 only. The number of terminal nodes is O of n. Number of those that represent the end of some string, because there are only O of n strings, and only we will move with DFS only through those. Well, still, we have first part to just create the trie plus n times 26, and there is one small annoying thing. Well, this part actually still should be multiplied by 26, because here for every new node I actually push back something of size 26. So, because I created this array, for every node I create 26 children, then this still is multiplied by 26. But if I used maps instead, maps to say for this character what's the new node, that would be for every node I would store a map from character to new node, or pointer to new node, to its ID, anything like that. If I had this, or an ordered map, even better, then I could say that this 26 doesn't appear here. For pointers to children. We don't need to use pointers. ID of a child is enough. But this array n by 26 is just very convenient. Oh, link was outdated, right? The whole time. Sorry about that. We were solving this problem. Hope it wasn't a big issue. Will you upload the class on YouTube? Yes, all the streams are even right now, because I double stream to Twitch and YouTube. They are here on channel Eric2 on YouTube. Any questions about this problem we solved? Bin.privacy tools. This really looks like a phishing link. Well, I will check it out. Maybe I will just ban you if that's bad. Yeah, like, what is that? I'm not sure if I should ban you or there is some explanation. So what is this website, privacytools.io? I opened it and there was no problem. Is it possible to initialize length of array with a variable? You can try. Well, if you want something of variable size, use a vector. So what, maybe now we should solve some problem about binary numbers to see how we can use tries there. And the one suggested by the Vilex might be a good choice. Any other approach than try and set? What, here? I showed you two completely different approaches. I think that's enough. Great. In paste bin this. Write a function that returns a string such as, and there are a lot of conditions. I don't think it's in any way related to try. But, you know, maybe try to create a random string and then check if it satisfies the conditions. If you would return to this code in a month, how easy would it be for you to understand it again? It looks quite complicated. You mean this code? Well, I understood what I did. So if you ask me in 1 month or in 5 years, I should be able to again understand it just because I understand the algorithm. Maybe, you know, looking at particular part of the code, like here, I will not understand in seconds, like what's going on here. I guess 0 means that something isn't assigned yet, but why do I push back this thing of size 26? Then I would need to think for a minute, oh, because just I didn't want one big array of size million by 26, I just dynamically assign more space. But the general idea, you know, I just understand. I think we should pronounce it try, not tree. But I'm not a native speaker, and I don't have a degree, especially in English, so, you know, but I mainly heard try, and I think it's try. Now let's see this problem suggested by the Vilex. You're given a list of positive integers. Return the maximum possible XOR of two values. XOR is that function that takes every bit, and if the two bits are different, like 0, 1 or 1, 0, there will be 1. Okay, how do we do this? The brute force is too slow because it's n squared. In n squared, we can iterate over pairs of elements. For each of them, we can check what's the XOR. That's not enough. N is up to 100,000, and with those constraints, you can only afford something like n log n, but not n squared. That would require around 10 to 5th power squared operations. That's around 10 to 10th power operations, while CPU is only able to do at most 1 billion operations, not even that, unless they are very, very simple. So, I mean, that many operations in a second. Let's say 10 to 8th power operations per second, then this should take 100 seconds. Those are very rough analysis. This code actually should be fairly fast. XOR operation is extremely fast. Comparing something or taking maximum is still quite good. But you will not get accepted like that. Instead, you need to focus on binary representation of on every number. And the idea might come from this. If you look at some number, like let's say this one, what would be the best possible match for this one to get big XOR? Perfectly, you want to get zeros and ones on different positions, like this. XOR of those two would be just all the ones in every position, so a very big number. But if you are to set at least 1 bit or 2 bits, then it's not that it's very important to here at the end have proper bits. No, it's most important to at the beginning have 0. If the first bit of that other number and then, is 1, just like here, and then you take XOR of those two, like that, you compute XOR, then you will get here 0 and some stuff, and here already you messed up. If possible, here we take 0. Then if possible, here we take 1. That's better because already we have prefix 1, 1 of this XOR that we maximize. We will greedily, for every next bit, try to get something of value different than the value in the first number. So the idea is this: iterate over first taken value, greedily choose bits in second value. But no, it's not that I can just say, oh, I take all the bits optimally. Like I choose first bit must be 0 because here there is 1. Second bit must be 1 because in the first number we have 0, and so on. Maybe there is no number starting with that, with 0, 1. Maybe I will not be able to finish this. We need to get a number that actually exists. And this is where TRIE comes handy, because TRIE is built only on achievable vertices. We can treat these as strings, and then every binary string you should insert into a TRIE. Now, there is a root, of course. And let's say there is number 0, then uses 1, then uses 0, maybe 0 again, and a 1. So here we have number 0, 1, 0, 0, 1. And there are some other numbers, sure. Let's say this is a TRIE. And now my solution will be for every number, so for every, say, number x in the sequence, what do? I look at the binary representation of x. Let's say that x is 1, 0, 1, 1, 1, 1. And I try to choose proper bits. If possible, I choose here 0 in the first position. In that matching number, I want to maximize XOR of two values. And when deciding what second value is the best, I first say it would be nice to put 0 on this position. So I go from the root to the left. I mean, I go choosing 0. I'm then here. And I know, because this node exists, it means there was at least one string or one number starting with 0. Then I try to put here 1. Is it possible? From this node, yes, I can move down, choosing 1. Then let's say that here we didn't have 1. Say we had 0. Then what? I'm trying to use 1 here on the third position. But there is no here node if we follow with digit 1. So I cannot get that. I cannot get 1. Instead, I need to have 0 here. And with 0, indeed, we can go down. And so on. That's the algorithm. For every, first create a trie, then for every number in the array A, we will, this is, let's say this first number is x. I look at its binary representation, and going from most significant bits, every bit in that second number, if possible, I try to get the opposite of what I have in x. Because this is x, and this is some kind of y that I'm creating bit by bit. This y must actually exist in the dictionary. This is why it's tricky to create it. If it didn't need to exist, then I would just, put all the opposite bits, opposite from x, and then I would have the perfect XOR of those two, with all the ones, maximum possible value. And one last thing is, it's easier to think like that if strings are of the same length, or if binary numbers are of the same length. So if some number is just 101 and another one is 11011, then the shorter one I can pad with zeros to the left. This number is still 101. I just padded to the left with zeros. Depending on what are the limits for AI, what are they? They didn't tell, are actually nums of I. Well, if they don't tell us the requirements, then we can just assume that nums of I are up to 2 to 31st power, because that's a limit, I think including that. That's the limit for type int. I hope that that's not the case. I hope that they are up to billion, because it's very annoying to deal with that last bit sometimes. No, smaller than. Right? It's from minus 2 to 31st to plus 2 to 31st, but exclusive, I think. So if that's the case, we have 31 bits to deal with, and the most significant one is bit, like 30th bit from the right. So eventually we will have somewhere here for every x in nums, x is the first value, and for every bit position from 30 down to 0. We will try to, if possible, choose this bit to be the opposite down from x. Do some stuff here. First, of course, build trie. Second, iterate first value, over what the first value is. Greedily build second value. But it must exist. This is why we need trie. At the end, we return some kind of answer, where always here, when we get to the end, I think here we will say answer is maximum with this XOR, where we created y, but also we needed node in, this is initially the root. We will move with this node, and yeah, first we choose the most significant bit, and so on and so on. Right, and then we will keep building y. Y is the second value. X XOR y is what we maximize. Here, if possible, I want bit on this position, on position j, to be different in x and y, but I do so only if trie allows me to move that direction. So if x and this way you can check this bit is on, it is 1. Then if possible we prioritize 0 to get nice XOR. If next of node 0 exists, then we move like that. Else we are sad and we do this. Also we should update y and we should update the answer. Else the opposite. This I think can be kind of code compressed into single if else, but I don't think that's very important. Make a video on how you move in editor. I move mainly with arrows and with a mouse, sometimes using home and, but that's really it. So if I know I need to go to the end of the line, I use end. Holding shift you can mark multiple lines or just some part, because keyboard is faster, arguably faster than mouse. Not arguably, it is faster if you know how to use it. When the y you find has smaller length than x, while the padding of zeros to the start of y guarantee that x XOR y is maximized? Because, well, XOR looks at values like this. If you need to compute XOR of those two numbers, of course I could write them next to each other if I wanted, like this. I need to compute those. The logic of computing XOR is put them so their right ends would be aligned, pad the shorter one with zeros, and then compute XOR. This is how XOR works. It moves one by one, let's say starting from least significant bits. This is also how you would add two numbers. If I ask you to add 5, 6, 7 with 12, how do you add it when writing one below the other? You would do this, and kind of, you don't need to really write it down, it's kind of hidden, but here you can say 0, and then you add them. 9, 7, and this is 5 plus 0, that's 5. Same happens with XOR. You don't really need to write this 0, but if we have a lot of numbers and we care about their sums or XORs, it only can help to write those zeros. If your algorithm then is easier to analyze in some way. But the y you found was optimized for the start of x, right? Yes, because in XOR you want to first care about the most significant bit. If, let's say, this is x, and I wrote this 0 just because some other numbers, they can have length of 6, so maybe we will be able to get in XOR, here there will be some second number, and when computing XOR, I hope to here get 1. So I hope that this 6th last position in x and in the other number y, it will be different bit. And if so, the XOR will have here a nice bit 1. And of course, when I maximize XOR, I start from maximizing the most significant bit. Can you help me solving this? Not right now, for sure. Please see my profile. Tips to improve. I have tips to improve. Here you go. I wrote them down a long time ago just because I got thousands of questions about tips. So, you need to practice, and the link I provided in the chat is my answer to how to practice, which is basically solve problems slightly above your level. If those that are a challenge to you, but they are not they are still possible, viable. And if you cannot solve it, go to editorial, read it, and learn it. If you don't understand editorial to some problem, then ask in Codeforce's discussion on that contest, ask the author. I don't think the stream about TRIE is a good place to ask. So Navin, what I can do without modifying and it will not modify the answer, is for simplicity, I pad everything to the same length, because then we can analyze XOR from left as well as from right. It doesn't change the answer, so just let's pad with zeros. Let's just because actually for computer an int is 31 bits plus the sign, so it's not that I do a lot by here using zeros. If you are saying that zeros at the beginning are an issue, then they would also be issue here. Did I go through any course? I went through thousands of problems. That's what I did. It's all online. Just solve problems, read editorials. If you don't understand something, if you don't know an algorithm, Google any tutorial on that algorithm. Right. So you know what to do here. We already built the TRIE. So treat this as your homework. The link is this, by the way. I will also put both links to problems we did today in YouTube description. And I will go now. This was a shorter stream. We will see each other in 1 week, just after CodeJam. Next Saturday, there will be Google CodeJam in the afternoon. After that, I will make a stream describing my solutions. Hopefully, I will do well and advance to round 3. But before that, there will be no streams. Usually, I stream 3 times a week. Follow me, YouTube, Twitch. But not this time. Next few days, I will be busy. Also getting my first shot of vaccination. Akash, don't make me ban you. I already told you that this is not a good moment to ask about editorial, and I told you what to do. Sina, same for you. Why? All right, everybody, join the Discord if you have more suggestions, if you want to join the discussion on my content and programming in general, and see you next week. Bye.